People often see UFOs spin very rapidly as they fly, and that might be why they have a disc shape, because something is spinning like that. And here's a schematic diagram from a crop picture. We have a wire coil here, something like this wire coil, and you can see something spinning very rapidly over it and it lifting up. So today we're going to study the physics of that. We're going to start from a wire coil like that, give it AC power. Over it we're going to put an aluminium disc with a DC motor attached, and we're going to see what the forces are between that aluminium disc and the wire coil, either when it's spinning or not spinning. Today we are going to study the effect of spin on AC lens levitation. We're going to start by putting an electromagnet like this. You can see the copper wire inside on top of a scale, and we've balanced the scale so there's no weight on the scale. It's all balanced out to zero. At 120 volts AC, the stationary aluminium disc pushes down by about 40 grams on the electromagnet. So the question becomes, when this disc is spinning very rapidly, will it still push down by about 40 grams on the electromagnet? I put the disc over it, and you can see the scale barely moves. It's not pushing down by anything near 40 grams. You can feel as if the disc is like a gyroscope with a life of its own. When I stop the spin with my finger, put it over there again, it pushes down by 40 grams for the stationary disc. When I spin it up again really quickly, put it over again, it doesn't push down, hardly at all. When I stop it with my finger, put over again, pushes down by 40 grams. Finally, we're going to put a very high 180 volts AC into the electromagnet, and a stationary disc, by lens repulsion, will push down on the electromagnet by about 80 grams. But if the aluminium disc is spinning very rapidly, 180 volts going to the electromagnet, then you can see the spinning disc does not push down hardly at all. You can feel as if the inertia of the aluminium disc is sort of holding in place like a gyroscope. No push at all. And then when I stop the spin with my finger, turn on the power, see it pushes down by 80 grams again. Then when I spin it up again, put it over the top, it doesn't push down. Finally, if the fast-spinning aluminium disc does not exert any downward force on the AC electromagnet, how do we know that the spinning disc doesn't want it to sit on top of the electromagnet, but rather wants to sit above it somewhere? We can't tell in this experiment because I'm holding the DC motor in my hand to hold the whole device upward. We did another experiment, however, where we set the whole thing horizontal, where I'm not holding it with my hand, it's sitting on a rod, and we can look at that to see whether it stays close to the electromagnet or moves further away. So what we're going to do now is spin this very heavy coil with a 12 volt power supply and the 12 volt DC motor, and we'll see what effect that has on Lenz's law. So if we spin it a little bit, the coil goes back a little further, a little gyroscopic stabilization. We spin a little bit more, and it goes back a little further, more gyroscopic stabilization. Spin a little faster, sits way up there, very nice gyroscopic stabilization of Lenz's law. like a top and spin it just a little faster. At your 2000 RPM, just sits there quite nicely. Very stable by gyroscopic stabilization. So today, for the first time, we have studied the physical properties of what's called spinning lens repulsion. If we have an AC electromagnet like this, we can give it AC voltages like between 60 and 180 volts, which make an alternating magnetic field oscillate north-south, south-north above the coil. If we put any conductor over it, for example this aluminium plate, that will cause reverse magnetic fields in the plate which spin around and make the plate lift up like that. Now that lifting force also pushes downward in a Newtonian sense on the electromagnet, so the weight of the electromagnet gets heavier by the same weight by which it's lifted up, which may be down 60 grams and up 60 grams. However, if we spin that aluminum plate very rapidly, say with that DC motor, now we see it lifted up, but there's no downward weight on the electromagnet, or hardly any. And also you can feel sort of a gyroscopic effect, a stabilization, spin stabilization of the rotating magnetic disc as it hovers above the electromagnet. It sort of doesn't want to wiggle. So this may be very relevant to UFO propulsion, and we will study that connection further in future videos.